Okay. I'm audible?
Yes, ma'am.
Okay, fine. I'll just share my screen. Okay. How many people have joined? Can I know the number? Okay, 17.
17, ma'am.
Okay.
Should we wait for 1 or 2 minutes?
Yes, I think we should wait.
Okay.
Okay.
Excuse me, sir, when will the valedictory section will start? Am I audible, sir?
Hello. Yes, ma'am. You're audible.
When will the valedictory session will start?
Ma'am, today at 12 p.m.
Okay. Okay, fine.
Okay, so I think we should start today's session. Good morning, participants.
Good morning, ma'am.
Good morning. Let me share my screen.
Morning, everybody.
Good morning. Okay. So it's the day 5 and we'll be doing probability distributions using R, and we'll be discussing binomial, normal and Poisson in this session, and rest you can do. Okay. So probability theory, Just a second. Yeah. Probability theory is the foundation of statistics, and R has plenty of machinery for working with probability distributions, and random variables. A probability distribution describes how the values of a random variable are distributed. For example, the collection of all possible outcomes of a sequence of coin tossing is known to follow the binomial distribution, whereas the means of sufficiently large samples of a data population are known to resemble the normal distribution. Since the characteristic of these theoretical distributions are well understood, they can be used to make statistical inferences on the entire data population as a whole. Every distribution that R handles has 4 functions. So what are the functions related to probability distribution? Probability density function, cumulative distribution function, then inverse cumulative distribution function, which is called quantile. Then PDF, everyone knows, it's a basic terminology for calculating the probability densities. Then R for random, a random variable. So just read this. Every distribution that R handles has 4 functions. There is a root name. For example, the root name for the normal distribution is norm, N-O-R-M. Okay, for binomial it is B-I-N-O-M. Okay, for Poisson it is P-O-I-S. Okay, so this root is prefixed by one of the letters. So for if it is P norm, small p norm, okay, if norm probability normal distribution is if suppose we have to calculate cumulative distribution of normal distribution, then we'll use small p norm. Okay, so norm is prefixed by this word p, but if we have to calculate cumulative distribution of binomial distribution, we'll write p binom. Okay, if we have to calculate cumulative distribution of Poisson distribution, it will calculate we'll be using p poise. Okay, so p, this P is important. It is for cumulative distribution function. This is all you have to remember. And Q is the inverse of P. Okay, so inverse of cumulative distribution function, that is quantile. For that we use the letter Q. Okay, and for calculating the density we use D. So if we are writing D norm meaning is probability density function of normal distribution. Okay, so D stands for PDF, meaning is probability density function. Okay, for discrete it would be probability mass function as you study. Okay, now R for random, R norm will be used for creating random numbers that follow normal distribution. Okay, so R for random, a random variable having the specified distribution. Okay, so this is the rule which we follow in R. Okay, and it goes for every distribution. Okay, so for the normal distribution, these functions are P norm, Q norm, D norm, and R norm. For the binomial distribution, these functions are P binom, Q binom, D binom, and R binom, and so forth. Meaning is for other distributions also, they are defined. Okay. For a continuous distribution like the normal distribution, the most useful for doing problems involving probability calculation are P and Q functions, because the density calculated by D function can only be used to calculate the probability via integrals, and R doesn't do integrals. Okay, so that is the reason why P and Q are more popular in this for normal distribution. Okay. For a discrete distribution like binomial, the function D calculates the density, which in this case is a probability fx equal to probability capital X equal to small x, and hence is useful in calculating the probabilities. For discrete, we use generally D binomial or D binom. Okay. Then R has functions to handle many probability distribution. The table below gives the names of the function for each distribution. So we are discussing binomial, normal, and Poisson in this presentation. They are the most basic ones. However, R can handle beta, Cauchy, chi-square, then exponential, F distribution, gamma distribution, geometric distribution, hypergeometric, logistic, log normal, negative binomial, 2. Okay, and these are the functions which are related to these distributions. Okay, so every time it is prefixed by P or Q or D or R. Okay, so it is easy to remember also. So let us first of all discuss normal distribution. The normal distribution is defined by the following probability density function, where mu is the population mean and sigma square is the variance. Meaning is sigma is standard deviation, and this is how f of x is given 1 upon sigma under root of 2 pi e power minus half sigma square x minus mu whole square. So all of you are familiar with the function of normal distribution, right? The probability density function of normal distribution. And if a random variable x follows the normal distribution, we write x, this curly thing, x follows. It represents x follows normal distribution. The first parameter is mu and the second parameter is sigma square. That's the variance. Okay, in some books it's sigma also. It depends on book to book, whatever notation you're following. Okay. So let us talk of normal distribution. Now, P norm is the function that calculates the cumulative distribution function, and all of you are familiar. If we denote cumulative distribution function by capital F, then capital F bracket small x is equal to probability that the capital X, meaning is the random variable that follows the normal distribution, is less than or equal to small x. So that is the cumulative distribution functions definition, right? So all of you please calculate do this operation. With this command, just do hands-on. You may start, right? P norm, then bracket 27.4, meaning is your x should be less than equal to 27.4, then mean 50, standard deviation 20. You can write in both the notations. Either you write mean equal to 50, ST equal to 20, or you write comma 50, comma 20. Please write both and you will find same answers. Okay. Is that okay? So it looks up probability capital X less than equal to 27.4 when X is normal with mean 50 and standard deviation 20. So what is the answer you got? Please tell me in your art studio. Just put this command and you will be able to calculate the cumulative distribution function of normal distribution. So please tell me the answer. Any one of you?
It is point.
Okay, let me.
It is 0.1292381.
Okay, just a second. Let me. This is not going. Just a second. Yeah.
So its value would lie between 0 to 1.
Yeah, its value would lie between. Yeah, it's 0.1292381.
Yes. Yes.
Okay, fine. Its value will lie between 0 to 1 because it is a probability, right? Probability that a particular thing is less than equal to 27.4. That a random variable is taking the value less than equal to 27.4, right? Where X is random normal variate with mean 50 and standard deviation 20. Okay, and you can write mean equal to S equal to also.
Excuse me, ma'am.
Ma'am, there are message in my computer laptop. Please are not installed.
Are not installed?
No, ma'am. No, ma'am. Means there is not installed package. R Studio package is not. There is no newer version.
So are you you're using R Studio? Are you
Yes,
using
ma'am.
but you used it, right? There had been no
Yes, ma'am.
problem earlier.
Yes, ma'am. But in the warning message, R graphics engine version 15 is not supported by this version of R Studio. The plot tab will be disabled until a newer version of R Studio is installed.
Okay, so might be the link with which you installed, there must be some problem in that. You can reinstall that. If you reinstall
Okay,
with
ma'am.
the link which I shared on the presentation, I have shared a link. If you
Yes, ma'am.
reinstall
Yes, ma'am.
through that link, I think it will work because it works in my computer.
Okay, ma'am. Thank you.
Okay. Okay, so these commands are not, you are not able to run these? PNOM 27.4.
Yes, we could able to.
What about Anjali? You're not able to run? Yes.
Ma'am, I am able to. Yes.
Achha, you're able to? Okay, that's okay. I think there is problem in some graphics thing, not in probability in your. Okay. So,
Okay, ma'am. Thank you, ma'am.
okay, fine. Okay, so you can use any of the command and it will give same output. Okay. Let us. Now, suppose I asked you to do this question. Suppose widget weights produced at your widget works have weights that are normally distributed. So it's given to you that if your random variable is widget weights, it follows normal distribution with mean 17.46 and variance 375.67. Now, since variance is this, you have to find the standard deviation, which is the positive square root of variance. What is the probability that a randomly chosen widget weighs more than 19 grams? So how will you calculate this? So yeah, it's saying what is the probability that a random variable chosen widget weighs more than 19 grams. So if X denotes the random variable widget weights
more than 19.
So you have to find probability X greater than 19, which would be 1 minus probability X less than equal to 19, right?
Yes.
And for X less than equal to 19, you can use the which function?
PNOM.
PNOM, very right. And then since you are given the variance, you will be you'll be finding the
standard deviation by taking
the square root.
Root.
So how do you calculate the square root of the function? It's by which function? How do you calculate the square root?
SQRT.
SQRT. So all of you, please do it and tell me the value.
So I will write PNOM within bracket 19.
Yes.
Comma, mean is equal to 17.46.
Comma.
Standard deviation is equal to under root.
Square root.
375.
SQRT. 375.67. You write PNOM, that's fine. You write 1 minus PNOM because that's the thing you want. So you'll calculate it again. So you can do it directly, right? So please do it.
Just a minute. Mean is equal to 17.46. Actually, shifting takes little time from one window to another.
Yes. Please tell the answer also.
SQRT is how much? 3?
375.67.
There is an error. Let me see. 10 - 19, 17. Yes, I'm getting 0.46833356.
0.468. Okay, fine. So anybody can confirm this answer?
Yes, ma'am.
Okay, fine.
Same here.
Fine. Okay, good. So you're able to do how to calculate these probabilities of normal distribution. Now let us come on to next slide. Let us talk about the quantile function. So this is the inverse lookup. Q norm is the function that calculates the inverse of CDF. Okay, so we call it F inverse also. So if your, small p is your capital Fx, if capital F denotes the cumulative distribution function, then small x is F inverse p. Okay, so you will be able to calculate the x. For Q norm, you'll be able to calculate the x, not the probability, the x. Okay. For example, the question is, suppose IQ scores are normally distributed with mean 100 and standard deviation 15. What is the 95th percentile of the distribution of IQ scores? Okay. So 95th percentile meaning is what? You have to calculate capital F inverse 0.95 when X has.
Actually, even in the, can you little elaborate? Even in the box plot, this percentile part is not clear. What is, I mean, since we don't use it, so like, what is the meaning of first percentile, third quadrant percentile?
Okay. I'll tell you. First percentile means whatever, how many distributions are, suppose your number of distributions are divided into 4 parts. Okay, first, second, third, fourth. Okay. Now median is the mid value. That is the 50%. Yeah. If you talk of 25%, that is the center. If you talk of 25%, that's the first quartile. Okay. And if you talk of 75%, that is the third quartile.
Okay. That means in the box plot, if my line is near the top, that means medium value is that.
Yes. If you are
of my problem, the mean.
Yes, if that highlighted one is that shows the median in the box plot.
That is shifted up and up, so I can say something about my data.
Yes, you can say what the median is towards the higher values, like this. Okay. Now the question is rephrased as F inverse 0.95 when X has n 100, 15 distribution. So in this case, how will you calculate? You have to calculate the 95th percentile. So that would be those values of X for which
X is greater than 95.
For which the probability is 0.95. Okay. So you will have to calculate like this. So what
Okay.
is the answer in this case? So what is the answer in this case?
Is 124.6728. I
Okay.
don't. Q norm, matlab, what is the meaning of Q norm?
Q norm is the inverse of the cumulative distribution function. Now, what is cumulative distribution function? That probability of capital X less than equal to X. Okay.
Yes.
So you have to think that way.
Okay, right.
So
right.
for what values of capital X, right? For what values of capital X, this probability is less than equal to 0.95.
Okay.
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 So let me come on to I've done this, right? Yes. So this I have told you. Now we talk of D norm. D norm is the R function that calculates the PDF of the normal distribution. As with P norm and Q norm, optional arguments specify the mean and standard deviation of the distribution. There is not much need of this function in doing calculation because you need to do integrals to use any PDF, and R doesn't do integrals. In fact, is not much use for the D function for continuous distributions. Okay. So D norm would D function would be used mostly for binomial distributions. Now we talk of R norm. Okay, we have seen Q norm, we have seen P norm. D norm is not much used for normal distributions. Now we see R norm. So R norm is the R function that simulates random variates having a specified normal distribution. As with P norm, Q norm, and D norm, optional arguments specify the mean and standard deviation. Okay, so we give one example. Suppose just carry out this example. Suppose you have to create random numbers which follow normal distribution with mean 100 and standard deviation 15, and you are creating 100,000 such numbers or 100 such numbers. So please run this command. Run all the commands. You may note down from the or I can share the pic on WhatsApp, because you don't need to switch then. So please run these commands.
Sent at the WhatsApp?
Yes, sent.
Okay.
Please see WhatsApp and just write these commands, all the 4 commands, just write them, run it later on. Okay. On selection or on bringing the cursor on right or left of the line which you want to run. Okay.
Actually, we can't cut and paste. We need to write, huh?
Yes, you write it here because it's very less, so you may write.
I will.
Okay.
So we have to run X. Yeah, our data is created. Yes, we could able to create the data.
Okay, and you can
And
see
this,
that data also.
yeah, I can see.
So you have actually created random numbers, 1000 random numbers with mean 100 and standard deviation 15. Now just run the next command.
Histogram. Hist x probability is equal to 2. So I am getting it the same. Acha, okay. When I'm typing hist x comma probability is equal to true, I am not getting anything in the answer. The same line is copied.
Okay, you're not able to run this. You just carry out hist x. Don't write probability equal to true. Then
Okay. No.
now also.
Now also. The same thing is copied. It's not running. Hist x is coming in the console.
X you are getting as the random numbers.
Yeah, I'm getting all the 1000
so
numbers.
This command write like capital HIST तो नहीं कर रहे आप?
नहीं, HIST, all small.
Okay, and nothing is appearing on the plot section.
Yeah. I got a histogram.
Yeah,
Sorry,
that's
sorry.
what I was thinking.
I got it. Yes, sorry.
Now just run this command.
Sequence.
Yeah. Meaning is whatever is the smallest random number and the maximum random number, and it's picking 100 random numbers from that. So XX is that sequence. Okay. So it's picking up 100 random numbers ranging from minimum to maximum. Okay. So you can see your XX also.
Okay.
Okay, so this is your Excel. And if you run it, here it's not showing. Just a second.
Length, with length you are getting brackets.
Yes.
So length is equal to 100 should be in bracket.
No, length equal to 100, then bracket over. Is that okay? Length equal to 100, then bracket over.
There is error. Object X not found.
So you have not run the X command or what? Something.
Acha, before this command, I have to again write X.
You may see. You may see.
Yeah. I check.
Should be recognized by our students.
Yeah. I think length is equal to 100 should be also in bracket. It's
No,
fine.
length.
Error in sequence default minimum x, maximum x, comma, length is equal to 100, object x not found. X is coming. I can see x.
Can you send the pic of the code?
Yes, yeah. Sent.
Okay, I'm just checking.
Oh, I have written capital X. It's okay.
Okay.
I got my error. Okay. Again. So will it show answer?
Yes. If you run this, it will show answer. If you run on
XX. Yeah, XX.
So in XX, 100 random numbers are stored. Okay.
Yes.
And if you plot these 100 random numbers, you will see, since they are random, you will get output as a bell-shaped curve, which is for the normal distribution.
Okay.
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 So normal distribution curve, this is what you know. The normal distribution curve is symmetric about
The origin.
Mean.
Mean.
And you see 100 is the mean. And if you run this lines XX denorm, then you get that this curve is clearly symmetric about the mean. That is 100. Can you see that?
We'll do this.
So these are 100 random numbers plotted and they follow normal distribution. It's clear from the graph, right? So actually you are plotting these 100 random numbers and you are joining it with line segments, but it line segments using lines function, but it shows as a curve because if we zoom it, we'll get the connected line segments. Okay, but it looks like a curve because these are 100 in number. Okay. Okay, so is this over?
I am not getting the answer.
Okay, you're not getting the lines.
No.
Are you not getting? Okay, so
I'm getting the same histogram.
Same histogram you're getting, but on histogram, are you getting the lines?
No.
Have you run that?
Yes, I have run. When I run,
Okay.
it's a line appear in the console. That's it.
Yes, line appears in console. Mine also it appears, but on histogram also a line comes as it's coming on the screen. Share your screen.
Let me see. Just a minute. I will do.
Okay.
XX denorm X. Maybe I have written something wrong.
Or you may send your pic also. That's also
denorm.
1 minus v naught x sequence you have written next max x.
It's 215 bracket. Don't know why I'm not getting.
Okay. Are you using same X throughout, like capital X, small
Yes,
X?
yeah, same X.
Same X. Okay.
Denom is D all small.
Denom, then you have written XX.
XX, comma, mean is equal to 100, comma, ST is equal to 15, and 2 brackets. Close.
Yes. Now you share the pic on WhatsApp. Okay, you have shared? Okay.
No.
Okay, just share on WhatsApp. I'll see that. Are you using capital X or small X throughout?
Small
You
X.
use-
Small X.
Small X you're using throughout. Okay, you shared. Okay, nice. X is fine. Then XX is a sequence of min x, max x, length equal to 100. Fine. Then lines XX, D norm, XX mean equal to 100, SD equal to 15. Okay. Then it's not coming. It should come. Maybe you can do one thing just now.
Okay.
Just open up a new script, copy this
Okay.
code, run there. And
Right.
I just want to see whether it gets run or not. Whether it's run or not. Just open a new script. Using plus sign you can do, or on file.
Yeah, I'm just copying.
Yeah.
So,
and run each line also, like
Acha, okay.
because X you're storing and everything.
Sorry, I did not get the same thing.
Oh, okay. Okay. What about his text? Did you write
Yeah,
probability
yeah.
equal to true?
Yeah, it is getting, his text is coming. His text is working. XX is I'm getting all the data, minimum to maximum. And but when I put lines wala command, then it is not working.
Okay. Okay. So might be some packages missing.
Yeah, some package is missing.
Yeah. So what you can do is, like, you can Google what package to be used for using lines function, and then you can install it on your computer, and you can call it through library, and you can use it. That
I'm
will
doing that.
solve the problem. Okay.
Yeah, I will. Yeah.
Okay, fine. Now we'll come to the next distribution, which is binomial distribution, and it's a discrete probability distribution. It describes the outcome of n independent trials in an experiment. Each trial is assumed to have only two outcomes, either success or failure. If the probability of successful trial is P, then the probability of having X successful outcomes in an experiment of n independent trials is given by this function, NCX, P power X, 1 minus, or you use Q power n minus X. So all of you know that this is the probability mass function or discrete density function of binomial distribution, right? And the function which is used to calculate is d binom, which calculate the probability function or probability mass function. Okay, so this is d binom is the R function that calculates the PF, meaning is probability function of the binomial distribution. Optional arguments described on the online documentation specify the parameters of particular binomial distribution. So in binomial, you were using the in normal distribution you use the parameters mean and standard deviation, right? So here you use the parameters small n and p, right? So small n you call size and p you call prob, okay, without dot. Okay, so these are the two ways in which you can calculate the probability mass function of binomial distribution. Okay, so where x is 27, n is 100, prob p is 0.25. So please calculate this value. You can use both the syntax. If you have the proper understanding of what is n, what is p, you can calculate. You may not use size equal to 100 and prob equal to 0.25. You just use it as parameters comma 100 comma 0.25. So this function actually looks up to the probability when x is equal to 27, not less than equal to 27. For less than equal to 27, we have the function small p binom. Okay. So it is exactly equal to 27. Okay. So just can you tell me the answer in this case?
When x has what is this? They look up p x is equal to 27, right? When x has the bin.
0.08
Has the
bin.
X has the bin. Bin means binomial. So this is how we generally do it in maths, not in R. For R, it's okay. Generally, whenever we are in maths, we always write bin n comma p. So that is the
right.
Can you tell me the answer, anyone?
Ma'am, yes, ma'am. It's 0.080640075.
Okay, 0.080.
Yes, ma'am. Yes, ma'am.
64075. Is it the answer you are getting, Alka ma'am?
Yes, ma'am.
Just a minute.
Okay.
Yes, I'm getting the same.
Okay, so this R can be used to calculate probability mass functions, and these involve very, very heavy calculations, right?
Yes.
Or you have to use some online probability mass function calculator, or you can use R also. Okay, so okay, so suppose this is a question. Suppose widgets produced at Acme Widget Works have probability 0.005 of being defective. So if capital X is the number of defective widgets, then small p is 0.005. Suppose widgets are shipped in cartons containing 25 widgets. What is the probability that a randomly chosen carton contain exactly one defective widget? So you have to calculate exactly one defective widget. If you name capital X to be a defective widget, number of defective widgets, right? Capital X is a random variable described as number of defective widgets. So what is the probability that capital X is equal to 1?
Uh, 1 by 25. Total is 25. And there is, what is the probability that it randomly exactly 1. Yes, 0.05.
Exactly 1 D by now.
Yes.
Okay. Please tell me the answer of this.
It's 0.11083117.
Okay. Okay, we'll confirm it.
Point 005 है ना?
0.005.
It is 0.11083117.
Right. Okay. So that's okay. So you're able to do the questions. Now, P binom is the R function. Now, what is P binom? It will calculate what? Since it is P, we have done D binom. Okay. So it calculates the probability mass function, right? What P binom would calculate? It will
Cumulative density function.
cumulative density, right? Okay, so if I write probability binom 27 size 100 top 0.25, it will calculate probability capital X is less than equal to 27. So if you have this question, suppose widgets produced have probability 0.005 of being defective. Suppose widgets are shipped in cartons containing 25 widgets. What is the probability that a randomly chosen carton contains no more than one defective widget? No more than one defective widget. Meaning is what? Probability x equal to 0 plus probability x equal to 1. It should not be more than 1, right? So probability x equal to 0 plus probability x equal to 1 is one answer,
Yes.
right?
Yes.
That is, you will be using the D function, right?
Yes.
And you can use it through
D
P
naught.
function also less than equal to 1. So you will use P function. So D function is, you have to write it 2 times, but P is directly you can calculate. For 0 and 1, meaning is less than equal to 1. So you can calculate using small p function. However, you can calculate it through D function also. In that case, you will have to add, right? So can you tell me the answer? Can you tell me the answer in this case?
P by now.
Ma'am, it's 0.9930159.
Okay, have I written right?
Yes, ma'am. Yes, ma'am.
Okay. Okay, Anjali, can you verify it by using D function also? So you will have to add
Ma'am, it's
0 and
Sabana.
1. Yeah. You have to add these two expressions which I have written on the board. Can you see that on my slide? So does it verify?
is getting the same answer.
Okay, so it's verified. It's verified also. Okay, that the use of D function and P function, right? So it's verified also. Anjali, are you able to get this verification also done?
Yes, ma'am.
Okay, fine, fine. So now let us talk about the Q function in D binom. So Q binom is the R function that calculates inverse CDF, and let us straight away come on to this example. So what are the 10th, 20th and so forth quantiles of this distribution which follows for n equal to 10, okay, and t equal to 1 upon 3. Okay, so can anybody calculate this? You have to calculate 10th quantile, then 20th quantile, then 30th, 40th together. So can you do that? So you are given n as 10, p as 1 by 3. So all of you first calculate 10th quantile. Okay. So when you have to calculate 10th quantile, you will have to write 0.1. 20th quantile, 0.2. 30th quantile, 0.3. Okay. 80th quantile, 0.8. 87th quantile, 0.87. Like this. So I ask you to find Q binom bracket the value of the quantile, which is 0.1, say, comma n, which is 10, comma 1 by 3. So how will you do this? You will do like this. You'll do like this. So I'm highlighting the command for 10th quantile. It would be Q binom 0.1, comma n, value of n which is 10, and the value of probability P, probability of success, which is P, which is 1 by 3 given to you. So what is the answer in this case?
Sorry,
One.
I
One,
lost.
ma'am.
Sorry, I lost in between as light went off. So,
Okay.
so
Okay.
what all I have missed? I
Okay.
did D norm. I did that one. Did
Okay.
norm of
We
x
were,
is equal to 1 and 1.
okay, we were talking of Q binom. Q
Okay.
binom is the inverse lookup, inverse of the CDF. So
Okay.
I take this question of calculating the 10th, 20th and so forth quantiles of a distribution T, where T follows bin in comma 1 by 3. Is that okay?
Okay.
Okay, so its 10th quantile, meaning is you have to use Q binom 0.1, comma n, comma p. If it is 20th quantile, you have to use Q binom 0.2, comma 10, comma 1 by 3. And if I want to calculate
Okay.
this, if I want to calculate 10th, 20th, 30th, 40th, 50th, 60th, 70th, 80th, and 90th quantiles, then I will be using this command Q binom sequence. Yes. So
Okay.
0.1, 0.2, 0.3 up to 0.9. So this is the minimum value of the sequence. This is the maximum value of sequence. And this is the increment by what you want and the other parameters. So I want you to give me the answers.
Ma'am, 1.
This is what? 1.
Shabana, 1.
Okay. Then what about this?
2.
Okay. And this?
I'm just
Yeah. Okay. So this would be the answer would be in a sequence form, right? It would be, you'll be getting output as a sequence because it would be 1, then space, then 2, then what?
By yes, I am getting.
Okay.
Ma'am, it's 1, 2, 3, 3, 4, 4, 5, 5.
3 is coming 3 times, right?
Yes, ma'am.
Yes.
Okay. So this is your answer.
1, yes, ma'am.
Is it right?
Yes,
I'm
ma'am. Yes,
also
ma'am.
getting the same.
Okay,
1,
fine.
2,
ma'am.
3, 3, 3, 4, 4, 5, 5.
Yeah, 1, 2, 3, 4. Yeah, fine, fine. So these are how many elements? 9 elements, right?
9 elements.
Okay, okay. So one more question.
So this is giving me the idea of inverse of the cumulative density function.
Yes, it is giving you 10th, 20th, 30th, 40th, 50th, 60th quantiles. Okay.
What is the significance where I can use this function?
You can use it in whenever we want to know, since it's probability, so it has use in predictions, right? So knowing about the 10th percentile meaning is how much population is below 0.1, then below 0.2, below 0.3, and so on. Okay.
Okay, okay. So that means if I have a data using this particular syntax, I
Yes.
can say something about how much is above mean.
Yeah. How much
below.
is, you can see it's all how much is less than equal to 0.1, it's 1, then 0.2, it's 2, so it's accumulating now. Less than 0.3, less than 0.9, it's giving the value 5. Okay.
Okay, very good. Great.
Now assume a random variable z is distributed according to the normal distribution with mean. This is the common question we generally encounter while we are always teaching to our students also. So assume a random variable z is distributed according to normal distribution with mean 6 and standard deviation 4. What is the probability that z takes on a value between -1 and 3? So when we have to calculate in normal distribution, it takes a value. If it takes a value less than equal to 3, we have this function. Okay. What is that function? P norm.
P norm.
If I have to calculate less than equal to -1, I have this function P norm. So now I have to calculate the value between -1 and 3. This meaning is till 3, I'll calculate and I'll subtract
minus
till -1. Okay. So this also we can handle through R, and this is how we will have to do. We'll write P norm 3, comma, what are the parameters? Standard deviation and mean. So mean is 6, standard deviation is 4, minus P norm -1, comma 6, comma 4. Okay. So please verify this answer.
is P.
आपको कॉलेज जाना है या
हाँ,
दूसरे
हाँ।
वालों का?
Ma'am, it's 0.1865682.
Okay, fine. So the normal distribution question came in between. Doesn't matter. I had to do it previously, but it's okay. So it's verified?
Yes.
Okay. Now we were on binomial. So try to do this question. Assume a coin is weighted. Means coin is not unbiased, right? It's weighted, means it's a biased coin. So that it comes up head 60% of the time. Meaning is probability of head is 60 by 100. That's 3 by 5. Yeah. What is the probability that you will obtain more than 25 heads? More than 25 heads after 50 flips. So more than 25 is probability x greater than 25. X is the number of heads. What would be what all functions you will use in this?
One minus probability x less than equal to 25.
Okay, fine. And for x less than equal to 25, which function you will use?
P-norm.
P
P-norm. P binom. Yeah, binom.
Okay, so it would be like this. Please verify your answers.
Ma'am, it's same answer. 0.902196.
Okay, so all of you have verified?
We have to take 25, 50 and yes. Why it is showing error?
Just see the syntax. All things are okay.
देख. It's 25, 50, 0.6. तो 0.6 के आगे 0 लगाना जरूरी तो नहीं होता ना?
नहीं. डेसिमल के आगे जो लास्ट के जीरोस है वो मिस कर सकते हो.
मिस कर सकते हैं ना? P बायोनॉम BIONM.
BINOM. बायोनॉम नहीं बायनॉम.
अच्छा. Okay, got it.
Now you got it?
Yes.
Okay, fine. Now come on to this question. So assume a standard die is rolled 10 times. What is the probability that you will roll fewer than 5 sixes? So capital X is the number of
assume a standard die is rolled 10 times.
Yeah.
What is the probability? X is less than 5.
Yes. So probability X equal to 0 plus 1 plus 2 plus 3 plus 4 less than 5 means till 4 you will do. Okay. So you will use P binom to sum the cases 0, 1, 2, 3, 4 and this is what you have to do. Is that okay?
Yes. What is 10 here? 10 times.
Because it was
N.
yes.
And it is N. Number of times.
Standardized roll 10 times. Yes, N is 10. Small p is 0.16. Why 0.16? Just calculate the value of 1/6 because they are saying 6. Out of when a die is rolled, you have 6 outcomes. So probability of getting any number is 1/6.
1/6.
So 1/6, you round off value is 0.16. This is what we are using.
Can you
1/6
can you show the problem again?
Okay, sorry. Yeah.
Okay. Yes. So I'm getting the answer.
Okay, fine. Now, just a second. Okay. So try this question. Suppose there are 12 MCQs in an English class quiz. Each question has 5 possible answers and only one of them is correct. Find the probability of having 4 or less correct answers if a student attempts to answer every question at random. So all of you tell me the answer only, okay? Just think how to get it.
बनाना है और
and while doing this question, you please verify your answer on your own through 2 functions, like cumulative one and density one, both the functions, mass function, okay?
Ma'am, is it 0.7945689?
It should be, you have taken, which function are you taking?
P bionorm.
P bionorm, right?
One is we have calculated P bionorm for 4 plus then sequence 0, 1, 2, 3.
So see, this is how you have to calculate. P bionorm 4. And since there are 12 MCQs, and what is the probability? There are 5 outcomes, right? 5 possibilities in one question. So it is what?
1 by
1/5. 1/5.
Yes.
So
This
that is
is
0.2. So
this is what I have taken, huh?
Okay, you have got this. And can you verify?
No, but it's not. It's written. Key question is just a minute. Question kya tha? What was the question? It was find the probability of having 4 or less. तो 4 भी हो सकते हैं, 3 भी और 2 भी और 1 भी और 0 भी. तो फिर हमें ऐड नहीं करना पड़ेगा.
अब हमने p बायनॉम जो यूज किया वो क्यूमुलेटिव के लिए ही होता है.
अच्छा अच्छा.
Right? That's why I'm asking you to verify it through D binom. If you verify it, you'll remember also. So I'm asking you to please do this calculation. D binom 0 plus D binom. You don't need to write size and prob word if it makes if it's time consuming to write all the time. You can write comma 12 comma 0.2 and you can copy paste and do it.
क्यों नहीं खाया इसने?
Yes, ma'am, verified.
Okay, fine. So Anjali, have you verified?
Just a minute.
Yes. Please, all of you verify. This
Yes,
also
ma'am.
helps in remembering you the difference between P binom and D binom. Okay. Okay, you have also verified. Fine. We'll wait for Alka ma'am also.
Yeah, verified.
Okay, fine. So we can use both the functions. Now the probability of, like, we generally make a conclusion also. So what we can infer from this, the probability of 4 or less questions answered correctly by random in a 12 question multiple choice question is 92.7%. Is that okay? So is that okay? If you are asked to make a conclusion, okay?
Yes.
So now we come on to the last distribution which we'll discuss in this session, and that is Poisson distribution. And all of you know how Poisson distribution is a discrete distribution, and this is how the probability mass function of Poisson distribution is given. Lambda power x e power minus lambda upon x factorial, where lambda is the mean, right? So the Poisson distribution is the probability distribution of independent event occurrences in an interval. If lambda is the mean occurrence per interval, then the probability of having x occurrences within a given interval is given by this formula. Okay, so all of you must have studied Poisson distribution somewhere. Okay, so let us try to do this question. If there are 12 cars, all the functions P binom, so P POIS, okay, like this only. So can you try this?
Find the problem 17.
If there are 12 cars crossing a bridge per minute on average, Find the probability of having 17 or more cars crossing the bridge in a particular minute. So let us think about solution. Okay, I'll just do it on this page only. Okay, so since it's the first question, you may think about the solution. So if there are 12 cars crossing a bridge per minute on an average, so in Poisson distribution, it's on an average. When this word on an average is given, it means what? In 1 minute, there are 12 cars on an average, meaning is mean is given to you. Okay. Find the probability of having 17 or more cars. So probability X greater than equal to 17, right? So that would be 17 or more cars. Okay. So probability X greater than equal to 17. So that would be 1 minus probability X less than 17, right? Is that okay? So 1 minus probability X less than 17 means 1 minus probability X less than equal to 16.
Yes, yes.
Right. So you will use 1 minus
P poise.
X less than equal to 16, meaning is 16 comma the mean. Mean is lambda equal to 12. So actually I have
okay.
Then you can calculate 1 minus P poise 16 lambda equal to 12, and you will be getting your solution. Is that okay?
Yes. Minus P.
Now one more thing. When we are calculating probability X less than equal to 17.
Do we have to write lambda or simply write mean?
No, LAMBDA. This is how we
Syntax.
write in Poisson. Okay. So actually it is giving us the lower tail, but you have to calculate 1 minus that. So either you write 1 minus P poise 16 comma lambda equal to 12, or you have an alternative. You can write P poise 16 lambda equal to 12. It will give you less than 16, but you then write lower equal to false. So it will give you upper tail. This is how it is done. So either use lower equal to false or use 1 minus. Both are same thing. Okay. So for simplicity, I think you can use 1 minus also, if you don't want to remember a lot of syntaxes.
See, there is an error.
You have written P poise, 2 P's.
Yeah. You have written 1 minus P poise.
Okay.
Poise is POIS. Within bracket 16, comma, lambda is equal to 12.
What spelling of lambda you use? LAMBDA. BDA?
BD. B क्या है? What is the spelling? LAM?
BDA.
अच्छा यहाँ B miss हो गया.
It's lambda. B is also there.
I got it.
Okay, you got it. So then you got it 0.10129.
291. Yes.
Okay. So you can make a conclusion also. So you can say if there are 12 cars crossing a bridge per minute on an average, the probability of having 17 or more cars crossing the bridge in a particular minute is 10.1%. Okay, a 0.1. Because on an average, there are 12 cars. So 17 cars will cross. Obviously, the probability would be somewhat less as we think of also
yes.
this real life problem, right?
Yes.
Okay. Okay. So this was the solution. Now one more question. Let's try this question. Or you may try another one. So a lot of questions I have given. You may try this. This is from Poisson distribution. Okay.
So mobile from a driving next to lens.
Just a second. Did I? Okay. Yeah. Assume a ball from the driving range next door lands in your yard at an average rate of 3 balls per hour during the day. Okay, so when average word is used, start thinking that you have got the mean. Okay, so what is the probability that 10 or fewer golf balls will land in your yard during the afternoon, assuming the afternoon is 5 hours long? So since you have to calculate it throughout the afternoon, and afternoon is 5 hours long, and you are given the mean for 1 hour 3, so what would be mean for 5 hours?
15.
3 into 5, right? 15. Yes. So what will you calculate now? Now you have to calculate probability that 10 or fewer golf balls. So if capital X is number of golf balls,
less than equal to 10.
X less than equal to 10. So for that, you have to use which function?
P poise bracket
P poise.
10,
yes.
comma, lambda is equal to 15.
Yes. Or if you are very much used to lambda, you can use 10, 15 also. That will save time. So please verify.
Okay.
So this command ppoise 10, 15, I want you to run. So do you get the same answer?
It's 0.1184.
Yes, yes, very good. Right. Anjali, you are able to get ppoise?
Ma'am, I'm also getting the same answer.
Okay, fine. So let us do one more question, which is somewhat a little bit different. Okay, so I thought of covering this also. So if a bird flies overhead at an average rate of 1 every 4 hours. Yes.
So Dr. Gunjan, sorry to interrupt you. It is almost 11:30 and we have to start our validity session at 12 p.m.
Okay, fine.
So,
I'll be sharing this presentation with all of you, and you may take a click of this in the break of, say, just a second. I'll ask you to take the click of my screen. However, I'll be sharing this PPT also after this session. Okay.
Okay.
So you can verify your answer through the pic, or I can send you this pic on the WhatsApp and you can try this question, and then we will stop this session. Okay.
Yeah. Is that okay?
Is that okay? So So I'm sending it on the WhatsApp group also. Okay, and you can verify your answer through that. Okay, and there are certain more questions also in the PPT which will do, and you will feel more handy with probability distributions in R. Okay, thank you. Thank you. I'll stop sharing my screen now.
Thank you so much, ma'am.
Thank you. Thank you
so much, ma'am,
Okay.
for the wonderful session. Now I request all the participants to fill the feedback form, which will be provided on the group. And the link of the Google form for the test will also be provided on the group. The link will be open from 11:30 a.m. till 11:59 p.m. today. So thank you so much, and I request all of you to join for the validity session at 11:55.
11:55. Okay. Thank you.
Okay.